Welcome to Chapter 20, 20.1. What are the causes and effects of water pollution? I don't know if you can see my face filming this in the morning, and again with the light situation, it makes it crappy to see anything. So first, point versus non-point pollution. Point, another way to think of point is end of the pipe discharge. Right. So here, this is the broken wellhead from the BP oil spill in 2010 in the Gulf. And you can see it coming out of the pipe. Here, you can see the erosion, the sediment washing in from, there's a pipe right here carrying it from wherever its origination point is. So, end of the pipe, smokestacks, ditches, the tailpipe of a car, easy to identify, therefore it's easy to monitor and regulate. Versus non-point pollution. Pollutants entering the environment in a broad or diffused manner. Urban runoff, residential lawns, as well as agricultural runoff. So anything, think for non-point, anything that involves a large area or a large square foot. All right. So, for example, here are some cows, and they're pooping. If you're actually watching the poop come out of one single cow butthole, that is point source pollution, because you can identify the butthole that it's coming from. Now, if you are downstream from these cows, right, and you detect fecal matter or E. coli in the water, at that point, that fecal matter is non-point pollution because you cannot trace it back to one of the cow's buttholes, right? So in a broad sense, if you know there's a huge farm that involves a large square foot area, therefore it has to be non-point. There's not one single place you're seeing it discharge from. Sources of water pollution, let me throw these up here. Agriculture, believe it or not, agriculture is the greatest source of water pollution, and it's not what you think. You're probably thinking it must be the fertilizers, it must be the herbicides, pesticides, etc. But you would be surprised. Industrial waste, mining waste, parking lot runoff, and plastic. This is a picture of a guy canoeing through, we'll talk more about this later, the Great Pacific Garbage Patch. It's a huge quantity of plastic from all around the world that gets caught in this gyre in this part of the Pacific Ocean. And in some places it's 90 feet deep and twice the size of Texas. Crazy amount of plastic. Slaughterhouse in Kenya. You can see the blood washing in there. So I had some additional facts on this one I want to read, make sure I get them. Okay, so for agriculture, the number one pollutant is agriculture, and in that subcategory, the number one agricultural pollutant is eroded sediment. Right? Think of all the tilling that we do. As soon as it rains, the water hits that sediment and washes it into the nearby streams and rivers and overloads that one particular area, causing a lot of turbidity, right, which is cloudiness in the water. If there's a lot of turbidity, then that decreases photosynthetic activity. If we lose the photosynthetic activity, then we lose the plants that put dissolved oxygen into the water. And we also lose habitat for small fish and food for others because they eat those small plants. They eat the small fish that hide in those plants, etc. And it ripples through the food chain or food web. So fertilizers and pesticides as well, livestock waste, parking lot runoff creates local flooding issues, right? Because the water in a heavy rainstorm is not dripping and percolating through the soil. Instead, it hits a flat surface and runs off somewhere, which can create local areas of flooding. Climate change is causing a huge issue with, I'm going to use a generic term here, toxins, for two reasons. One, if you get a huge increase in rain, if there's a lot of pesticides, herbicides, or other toxins spread over the land, it will wash, excess rain will wash more of that into local streams and rivers than under normal rain conditions. So then you say, okay, well maybe less rain is better. Well, if we have not enough rain, if we decrease it too much, then what happens is there's not enough new water flowing into lake, stream, river. So what happens is the pollutants stagnate, they're not diluted enough, so it just kind of concentrates the toxins. So too much and too little water are a bad thing. And last one, 1 out of 6 people worldwide do not have access to clean drinking water according to the World Health Organization. This is a table found on page 534, table 21. It's a good idea to go through and be familiar with it, especially when it comes to your FRQs, because it gives you all the different types of major water pollutants, where they come from, right? Where's the source of this pollutant, and some examples of that pollutant, right? So that's great for when you're answering an FRQ and it asks you a problem or a type of water pollution, or if you're using it in an FRQ as something that humans have done to destroy biodiversity, perhaps, like one that we just had. Instead of using a generic term like water pollution, you can now get specific, say what it is, where it comes from, and then throw in how it affects the ecosystem or the food webs or biodiversity. Same thing, here's another one for table 20.2, also on page 534. And here are some 3 major examples. This one right here, this first one is a type of worm. Here's some information on it. Schistosomiasis, crazy. This one affects more than 200 million people in the world. Second to malaria, and it's considered one of the neglected tropical diseases. Jimmy Carter, however, is working on this one, and he has, if you guys remember the life straw that we looked at in class that removes bacteria and small microbes, he's got one that specifically works with this one. And when you suck water through the straw, it removes the eggs, which would then get into the people. And what happens is then they start carrying out part of their life cycle within you and in your digestive tract, and then when you poop out these guys, and sometimes you poop out some of their eggs. So the eggs float into the water, and the next person drinks the water and it gets inside them. So the straw actually filters out those eggs, so you don't get it. First top right one right there with the little flagella tail, a single flagella tail, that is cholera. That is a bacteria. Right, so that would be filtered out through the life straw, and this is one of those that cause diarrhea. You can see a lot of these effects is diarrhea, which dehydrates the person. What else do I want to say about cholera? It affects 3 to 5 million people every single year, and in 2010 caused 130,000 deaths in third world countries. And then Giardia, this one right here, this protozoan. We just did our protist lab, or we're currently doing it, and you guys are seeing different protists that live in the waterways. Right? So luckily the ones that we're looking at do not cause any type of diarrhea or dehydration, so you're fine. But just to give you an idea, it's in the same order here, so just think back to what you're looking at in the water. Those little tiny microscopic organisms and how many problems they can actually cause. And this one affects, how many people does it affect every single year? About 2.5 million people. That's crazy. Okay. Next slide. What is a good indicator of water quality? No coliform bacteria, right? E. coli, again, which comes from fecal matter. This is mainly a problem in third world countries where they have a communal pooping area that contaminates their groundwater supply. So what's safe for drinking? No colony forming units, no CFUs. Okay, CFUs is, you're looking at how many individual cells of bacteria in the sample under those current conditions can then survive to produce a full-fledged colony, multiple cells, right? So say for swimming, no more than 200 colonies for half a cup of water. So why can you have some when you're swimming? So hopefully you're not drinking it, number one. And number two, whenever you go swimming in a public pool or even your own pool, you're jumping in, and you may not have just gotten out of the shower and scrubbed the crack of your butt. I know it sounds gross, but you have pieces and particles of poop in there which contain E. coli. And all that gets washed out while you're swimming. So when you're swimming in a public pool, if you can't smell the chlorine, don't get in it, right? Because you need the chlorine to kill the E. coli that's in the fecal matter that's being washed out of people's butts as they're swimming around. So again, drinking, no E. coli. Swimming, 200 colonies per 100 milliliters, or half a cup. And that is the end of 20.1.